Class, at the end of the class, I return your case reports to you guys, to at least one teammate, except one team. Okay, nobody was here, so I think Trinity gets your team's report, right? So, and also I already post your group case study score in the Blackboard. So if you have a question on my grading or you want to discuss about case reports, feel free to come to my office after class or we can discuss. Okay, so homework. So remember, what is the due date of our homework 2? Next Wednesday, very good. So I already tell Michael Smith, who is our tutor for this class, about homework 2, and he's ready to help you guys. Definitely, I'm always ready to help you guys. Feel free to come to my office. Okay, don't wait for the last minutes for homework questions. So I think now you can do most of the questions in the homework except the last one, single period model, but we will go through this model today. I believe after today's class, you should be able to do all the questions for homework. Okay? Questions, comments? No? Okay, quick review on what we have learned so far on chapter 13, inventory management. So the first model we have studied is called basic EOQ model. What does EOQ mean? Anybody remember? Very good, Joseph. So economic order quantity model. So for this model, give you several assumptions. Okay, if we satisfy these assumptions, then we can use a very simple formula. Q equal to square root 2ds divided by h to get the optimal order quantity for this retailer or distributor. Right? So remember that this formula guarantee we have the optimal solution. Okay, guarantee we have the optimal solution, which means if you use this order quantity, your total annual cost will be minimized. So that's the EOQ model. And later on Monday's class, we went to the EPQ model. What does EPQ mean? It's right here. Economical production quantity, right? The difference between EOQ and EPQ is that the middle letter, right? We replace O with P, right? You can see, now you can see the difference. Order versus production. The difference reflects the people or the organization use the model. If we talk about EOQ, most likely we are talking about you are in the supply chain system, you are in the downstream position. You think about supply chain system, right? Manufacturing, distributor, and the retailer, right? So for EOQ model, it definitely fits very well for the distributor and the retailer, because if you are in that downstream of supply chain, you don't produce anything. You just purchase, hold that, sell them. So EOQ, optimal order quantity. But if you are in the beginning position, upstream of the supply chain, then production plan is a very critical thing for you to be successful in the industry. So that EPQ model will fit better going in this position. Okay? So we use this formula, very similar formula with EOQ, with only add a coefficient, square root P divided by P minus U, right? The ratio of the production rates and the difference between the production rates and demand rates. We get EPQ. We went through this big example last class. Okay, I think you guys did a very good job. Okay, today we introduce another very important model. Yes, but okay, we already talked about different players in the industry. EPQ, EOQ seems they're good, but sometimes those two models are not enough. Think about one situation. It's called a single period model. So that's a nickname of this model. Okay, historically, it's not called a single period model. It's called a newsboy model. Newsboy. Do you guys know what is newsboy? Newsboy?
Is that like a paper boy?
Yes, that's right. Rins, you are correct. So that's newsboy. That's early in the morning. He purchased a lot of newspaper. He decided how many newspaper do you want to purchase and sell them. Think about a newsboy in Manhattan. Okay, his job is to purchase the Wall Street Journal and stand on the Fifth Avenue in Manhattan every day to sell the Wall Street Journal to customers. Then, this is very important for him to decide the optimal order quantity early in the morning. How many newspapers, how many Wall Street Journal you want to purchase today? But this is very special compared to the previous model we have mentioned. It's because this newspaper, it's not like food, it's not perishable, but you think about after the end of the day, does anybody still want to purchase Wall Street Journal for yesterday? No, right? It has little or no salvage value if we pass the day. Right? So if you talk about the newsboy, he has made a tough decision because if he purchased too much, the leftover almost mean nothing. You can't carry on to the next period. When we talk about EOQ, EPQ, we know that we can carry on this inventory to a very long time period. But for newsboy, it's very tough for him. He can't carry on. But on the other hand, he doesn't want to order too little, right? Because otherwise he will lose a lot of customers, a lot of revenue. So you can see in this situation, the newsboy only consider today's demand. He shouldn't worry about tomorrow, right? Because what's happened today won't carry on for tomorrow. Inventory can't carry on. And also shortage, you can't back order. You think about another thing is that you sell newspaper. Okay, customer come to you and say, oh, do you have Wall Street Journal today? I don't have that. I can give you tomorrow. Nobody wants that tomorrow for today's newspaper, right? So there's no back order. Okay, the salvage cost is all very low, almost zero. In that situation, we should consider single period model. Well, definitely single period model not just used for newsboy. Any perishable products such as food, such as even like the seasonal products, event products, like holiday events products, they all have this very strong pattern. We should consider single period model. Now, let's see for the single period model, how can we decide the optimal order quantity? Give the recommendation for the newsboy. Right? So there's two costs we have to consider for this single period. We just focus on this period. Right? First one is the shortage cost. It's easy to understand. That means if this newsboy purchase less than required Wall Street Journal, and there's a shortage cost per unit. Generally speaking, is the unrealized profits. So it's very easy to estimate. It's the revenue per unit minus the cost per unit. Think about if he purchased the Wall Street Journal by 50 cents per unit, sell is $1 per unit. Then what is the shortage cost for this newsboy? $1 for the selling price, 50 cents for the cost. What is the shortage cost? It's a hard question. The selling price is $1 per paper, right? The ordering cost is 50 cents per paper. Then what is the shortage cost?
50 cents.
50 cents means very good. It's very easy, right? So it's unrealized profits. One thing I want to remind you, okay, everything we teach here is the basic model. In industry, in reality, when you estimate this shortage cost, usually it's higher than this unrealized profits. It's not just, okay, I don't have a newspaper today, so I lost 50 cents because I can't sell to you. No, usually the shortage cost is much, much higher than the unrealized profits. Do you know why? Why in reality, in industry, the shortage cost is much higher than just unrealized profits?
You lose the customer.
Customer, and very good. Because the customer, you can permanently lose the customer. Or not just today. Okay, you didn't get these 50 cents today. Well, this customer can switch to some other newsboy or newsgirl, well, to get the Wall Street Journal tomorrow, next week, next year. So usually in industry, when we estimate the shortage cost, it's much higher than that. But here we just introduce the basic model. It's easy to understand, right? Definitely this is part of the shortage cost. But in our model, let's say this is shortage cost. But you keep that in mind when you work for the real projects later. Okay, shortage cost usually is higher than just unrealized profits. Excess cost. This happens if you have more inventory than the demand. Right? At the end of the day, okay, you have 100 extra newspapers. It doesn't mean too much. Right? So it's a difference between the purchase cost and the salvage value of items left over at the end of the period. When we talk about newsboy, the period is 1 day. When we talk about some perished food, the period can be 1 week. It really depends on the expiration dates, or 2 weeks, 1 month. But we calculate at the end of the period, daily or weekly or monthly. Right? So it's the cost per unit minus the salvage value per unit. Well, just pay attention to here. Some product, they have some salvage value. They have some, right? So I have leftover, you can still sell them. Newspaper, probably they have some, like just sell by the wasted paper. But some have zero salvage value. You can only dispose it, right? Food, for example, okay, you can't sell to anybody. You can just dispose that. Some has negative salvage value. You dispose that, you have to pay the money. So that means, okay, you minus the negative value, it's even higher than your original purchase cost. Keep that in mind. So salvage value can have any size, positive, negative, zero. Right? Definitely the cost per unit is positive. So now we know how to estimate these two costs, right? Shortage cost and excess cost. So I want to write down this for you guys. So shortage cost, CS, is equal to revenue minus the cost. CE is the cost minus salvage value. Okay, now we can move forward to the model. So the goal for this single period model for the newsboy is to identify the optimal order quantity that minimizes the long-term excess and shortage costs. So there are two different categories of the single period model. One is depends on the distribution of the demand. One type is that if your demand is follow continuous distribution, such as normal distribution, gamma distribution, different distribution. Another type is demand follow discrete distribution, like a binomial or some other distribution. Right? Then we will consider different situations. But the optimal service level is always this, no matter what is your demand distribution. So it's very easy to calculate. It's CS, which is the denominator, okay, shortage cost, divided by CS plus CE, which is the denominator. Sorry, CS is numerator. So CS is the shortage cost and CE is excess cost. So again, in this management class, we don't require you guys to know how to guess this optimal. Okay. Same idea as we have done for EOQ or EPQ model. Okay, we write down the total cost function. Okay, it's the function of the service level and take the first derivative equal to 0. We solve this equation, we get this. Okay, just trust that one, you understand, right? But the calculus, we guess the optimal service level is this critical ratio, CS divided by CS plus CE. So that's the service level. CS divided by CS plus C. Okay, now it's your turn. Alright. Everybody gets the formula. Alright. Everybody understand? Okay, when we talk about perishable food, perishable product, and then we should use single period model. Let's see this example. Sweet cider is delivered weekly to Cindy's cider bar. So demand varies uniformly between 400 and 600 liters per week. Now I want to ask you guys, what does this mean? The demand varies uniformly between 400 liters and 600 liters per week. I think you should perform very well because Dr. Kang is here. He has taught you guys statistics before, right? You should understand that. So which distribution we're talking about now? The demand distribution. Who was in Dr. Kang's class? Raise your hand before. Who was in Dr. Kang's class? Okay. Dr. Kang, he's really looking at you guys. Right? So he definitely teach you guys that. I guarantee, right? Not really? Oh, normal distribution, right? But not. Yeah. So this is uniform distribution, right? Because it's told us it's uniform distributed. Okay.
We covered that.
You cover that. Right? Okay, come back to retake the statistics class. Okay, so it's a uniform distribution, right? What does uniform distribution mean? From 400 liters to 600 liters. What does this mean? Anybody remember? What does this mean? This demand pattern, what does this mean? Uniform between 400 to 600. This means the probability for any demand between 400 and 600 is the same. So that means 400, 401, 402 until 599, 600. they have the equal opportunity, equal probability. So that's a uniform distribution. You have to use that. The reason is that you have to use that to get your optimal stock level later. Okay, now we know it's follow uniform distribution from 400 to 600 liters. And Cindy pays 20 cents per liter for the cider and charges 80 cents per liter for it. Then we know that. What is the cost for this cider? Purchase cost. Anybody can tell me? What is purchase cost? 20 cents, very good. What is the revenue per liter for the cider?
60 cents.
Revenue.
80 cents.
80 cents. Yeah, 6 cents. You guys move too fast, right? It's profits, right? We're talking about profits very soon. Unsold cider has no salvage value, which means which value is 0? Salvage value is 0, right? So we get everything. We know the revenue 80 cents, cost 20 cents, salvage value 0, right? Now you should have everything you need. And then unsold cider has no salvage cost and cannot carry it over into the next week due to the spoilage. Question: find the optimal stocking level and its stock out risk for that quantity. So the first, before you calculate the optimal stock level, you definitely want to calculate service level first. After you get the optimal service level, then use the distribution, uniform distribution, to figure out, okay, if the service level is like 90%, whatever number you get, then given this demand distribution is uniform, what is our optimal stock level? I'll give you guys 20 minutes, should be enough? 15 minutes to do this question. I will walk around to help you guys. No pressure, right? You don't have to take the statistics class. Just have to review that, okay? That's the reason we have this pre-request. No, it's a single pin. Single pin. Yeah, that's correct. So that is the optimal service level, 75%. Yeah. After you figure out 75% rest, what is the optimal stock level? See something already figured out the optimal service level. What is the optimal service level? 75%. Yes. Okay, that's the easy part. Yeah. Given the demand distribution, given we want to satisfy 75% of our customers, that means we can afford 25%. Okay, customers have shortage. Then what is our optimal stock level? Well, first thing you should know that your stock level should be between 400 to 600. There's no points you have less than 400 because you know that reach 400 you can sell all of them. There's no points you have more than 600 because you know any number above 600 you can't sell them. That's what is the optimal number between 400 and 600. Given the service level is 75%.
550.
You get that, Alan? Very good. You are not in Dr. Khan's class before?
Online.
Online, okay.
He wasn't here. I couldn't talk to him. So, but if cost, the revenue minus the cost is 60, because it costs 28. And 80 minus 20 is CS
This CS
plus
plus
CE, which is 0. Because
C is not 0. C is the cost minus salvage value.
Right, the cost is 60.
Cost is 20.
Oh, 20, then I'm sorry, yeah, 20. Yeah.
But how did you get the service level of 75%? Because I got 1.5.
CS, okay, plus C.
Oh, plus.
Plus, yeah.
You should guess a percentage, you know, between 0 and 1. This ratio. Good. That? Yeah. What is optimal stock?
That number he found.
CS is randomized. What is RAM?
I mean, like this.
200 liters.
And service level 75, so 75 out of 600 is
You know how to get 75%? How about you?
Yeah, I got 75%.
Okay.
yeah, I got 5.
Zero.
Trying to figure out.
Really? Yeah. I know you guess the idea, but formula is not correct. Yeah. You guess the idea. You know that newly converted.
It's not today.
Easy, right? Once you understand the distribution, then we become pretty
Yeah, it's on my camera.
Oh, see, some students already solved this problem. Okay. For example,
Oh, I get it.
I don't have the definitions on them, all the questions. So just like study them, because how does these all from memorization?
where you get this number?
I kind of like tested myself, so I was like,
Huh?
what?
You heard? Okay. Try to figure out that.
So, I get it now. I'm trying to figure out how to get it.
Let's give you guys, I don't know, some time to try to figure out that. Okay, you are on the right track, Eric. That's the exact answer.
I have
I don't even know.
other users 600 minus
I'm stuck. I don't know. What's the next step? I'm not understanding what I'm supposed to say. I don't know where I'm supposed to be like 8 questions. Like answer
Labor has been deep.
like definition questions. So like
Well,
answer
that is 75%.
I'm not sure whether your formula is correct, but you'll be done with it. I don't think it's correct, but
it's like what I
okay. Let's do it together. Let's do that together.
What I don't know is the
So the
last part.
first part, anybody can tell us what is the CS? How do you calculate CS in this example?
80 minus 20.
80 minus 20, so 60 cents, right? How do you calculate CE?
20 minus 0.
20 cents minus 0, so it's 20 cents. Then the optimal service level is become very straightforward, right? So it's 60 divided by
80.
60 plus 20, 80. So you guess 75%. You can write down 0.75, it's the same. So what does this mean? That means, okay, we know that given this product is perishable, okay, we want to keep our service level 75%. Means with the probability of 75%, we can satisfy all the customers' order requirement. With 25%, in fact, I already answered the question, what is the stock out risk? 25%. Well, 75% is service level. Then 1 minus 75% is the stock out risk. Okay. With 25% probability, we can't satisfy all the customers' requirements. We experience shortage. But we know that it's optimal, given our cost estimation is optimal. Okay. You understand, right? Not always 100% is optimal. Usually it's less than 100%. Most companies says 85%, 90%, 95%. As this example, we know 75%. Okay, everybody get that, right? Optimal service level. So next question. Given this optimal service level, what is your optimal stocking level? how many liters you want to have on hand at the beginning of the period, at the beginning of the week? That's a question Cindy has, right? Anybody?
550.
Dylan, Alan, and silent Joshua. You finish first, but you do want to keep silence. That's fine. So, yeah, 550, right? Anybody? You three, or maybe some other student you want to figure out? Can tell us how do you guys 550?
The distribution would be 600 minus 400.
Okay, 600 to 400 to 600 is a uniform distribution. We use U, 400, 600 to demonstrate this distribution, right? It's uniform. The uniform distribution has the same probability for every value between this interval. So Dylan said, okay, the optimal stock level you use 600 minus 400,
Yes.
then what?
Which equals 200.
Mm-hmm.
And then you'll times that by 75, which is your service level.
75%. Mm-hmm.
Which equals 150.
Mm-hmm.
And you add that to the minimum.
400. Right? That's 550. Liters. Okay, I write down here. I believe even after I write down this formula, somebody still have questions. You have questions? Last question, right? Why is that formula? Okay, give a simple example. Let's not talk about 400 to 600. Let's talk about uniform distribution 1, 2, 3, 4. So that means, okay, well, 25% probability is 1. 25 2, 25% 3, 25 4%. 25% probability we get 4. Then given this simple uniform distribution, if we want to have the 75% service level, which quantity should hold? 1, 2, 4. 3, right? If you hold 3, okay, 25%, the order quantity is 1. You are good, you have 3, right? Another 25% quantity is 2, you are good, right? Another 25% quantity is 3, you are also good. The only problem is like if the order quantity is 4, then you can't satisfy. So that means for simple distribution from 1 to 4, you get 75%, you get 3. And then how do you calculate these 3? You don't have to count this way, right? If you have this distribution from 1 to 4, right? To count as is that, okay, we know, right? The minimum value for this distribution is 1, so it's the base point. Plus the 75 percentile. We want to know 70 percentile corresponds to what range? The range is 4 minus 1, the maximum minus minimum, right? Times 75 percentile plus 1, you get 3. Right? It's clear, right? You think about student GPA, average GPA is the same thing, right? Use the minimum one plus the percentage of the range. We talk about range, right? That's the range, 4 minus 1, we get 3. So this example, okay, we only change the number. Now it's not 1 to 4, it's 400 to 600. But same idea, right? 400, this is the minimum value, plus the range of this distribution times the percentile, 75%. Finally, you guys 550. Better? Clear? Okay, a little bit. But yeah, you may, if you have concern, you may want to review what is uniform distribution. Right? Don't can't just confirm that he has taught that.
So what's that, 3%?
3?
Yeah, the
This is just an example.
Oh, okay,
Yeah,
sorry.
yeah,
I
just
thought that was,
erase
I
that,
thought that was
right?
part
Okay.
of that.
I just
Sorry.
erased this. I just want to give you a very simple example. Okay. Then in that example, you don't need to know the formula. You can figure out by yourself. That's for this one. We really need the formula. Question? Comment? Good. Okay. That's the end of the story, right? Let's deal with the second part. Cindy also sells a blend of cherry juice and apple cider. Demand is a normal distribution with mean 300 liters and standard deviation 10 liters per week. What is optimal stock level? Give you guys 5 to 10 minutes. For the first, the optimal service level is the same, 75%. You don't have to calculate again. The only difference between the second part and the first part is the demand distribution. Now it's not uniform. It's a normal distribution. Definitely you guys have no normal distribution, right? Normal distribution, 75 percentile. How do you guess the value? You have a textbook. Definitely. You still have a textbook. Now you should turn to the appendix. That's appendix. So the appendix will tell you, given the percentile of the normal distribution, what is the critical value. And then, long time ago in statistics class, you know how to do that. I'm not sure whether you still know that now, but try. What do you call your memory? Discuss? Nobody remember? And we should teach statistics every semester, right? It's not this one. It's yeah, that's good. Yeah, that's good. Yeah, exactly. That's table 75 percentile. Know how to find the 75 percentile? Just look at the table. Find 0.75 is here, right between 0.67 to 0.68.
Okay.
Yeah.
The best table you can use is this one. Right? This will give you the probability below this number. Appendix, I believe appendix C or B, the normal distribution appendix.
The mean's 300.
Yes.
Average.
Standard deviation 10.
Deviation says 5 on each side.
You get that?
Is that it?
I don't know how to use it.
That's the critical value?
No.
How's that not the critical value?
0.6. I can see here 0.6.
Point
7 between 0.67 and 0.68. Alright, that's 75%. Look at the table. You can't look
Oh,
at from
the
here. Look at the table.
percentile. Oh, okay.
Well, that's the reason I asked you guys to
So-
look at the table. Get that? Okay, that's right. Good, good. But still, one step away from the final answer.
Is this one?
Yeah.
So you look at 75.
Yes. What is the value? Beat the value.
0.7.
Or, yeah.
No, 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 no.
But, that's odd.
No, that's not right, Anna. You could look at the table to get 75%. So it's between
between
this
there
and
and there.
yeah.
Right.
That is 0.67, between 0.67 and 0.68.
0.68.
Yeah, you can use any number, 0.67, 0.68, or somebody prefer 0.675, something like that. Doesn't matter. You get that?
I usually bring it.
That's okay. That's okay. Okay. Since many students don't bring your textbook today, and I want the student with the textbook to tell us, for the normal distribution, correspond to 75 percentile, what is the critical value for the normal distribution? 0.675? How do you get it?
They're like in between 6 and
Yeah, so if you go to our appendix B or C?
B.
Appendix B, that's the normal distribution table, which page?
868.
Page 868. So you should guess that. You find this percentile, 75%. You guess critical value is between 0.67 to 0.68. Okay, you can use 0.675 or any number between 0.67 and 0.68. I accept that. Right. If you go to Google, you probably have a very accurate number, but this table, right, there's no exact number corresponding to 75%. Okay, So everybody gets that, right? So the critical value 0.675.
4 and 75.
Then what is optimal stock level given this distribution?
0.6.
300 is the mean, standard deviation is the 10. Then what is the optimal stock level? .675. How do you use this critical value? Remember, this value is critical value for the standard normal distribution, which means if your mean is 0, standard deviation is 1, then 0.675 corresponds to 75 percentile. And with a normal distribution, mean 0, standard deviation 1. But now we have a normal distribution, mean 300, standard deviation 10. We know, that's impossible. 0.675 can get 75 percentile for this distribution, right? So that's a standard normal distribution. Then that's the formula. Long time ago, you guys really know this formula. That's maybe for you guys. Some of you like just 3 months ago, 4 months ago. If you take a class in summer, nobody remember? We have all the information we need. I have to bring Dr. Kang back, right? Or Bishop, or Victor back. I don't know who teach you guys, but they're all fantastic professors. I trust them, but I also understand that's the memory,
Yeah, don't
right?
use it.
Yeah, memory is short. Everybody.
I have a lot to remember.
No, no idea.
No.
We have this critical value 0.675. Okay. Do you know some magic formula about normal distribution? How do you convert the standard normal to the general normal distribution? Mu is the mean plus z sigma, something like that. Do you guys remember that? Mu plus z sigma. Okay.
In
You said mean plus
Yes. Yes.
I know you
So mu is the mean plus z is the critical value times sigma, which is the standard deviation. This will give you the critical value for the distribution. Follow the normal distribution means mu, standard deviation sigma. So if your mean is mu and standard deviation sigma, you use this formula. Instead of just use 0.75, you should guess the critical value for this normal distribution. Now, what is mean? What's the mu here? 300, right? What is sigma?
10.
10. Plug them in. You get that, right? Anybody remember now this formula? Dylan? You remember now? Kind of, right? Joshua? Still don't remember that? Mu plus z sigma. I'm pretty sure that your professors have taught you guys about this formula. Yeah.
So would z be our critical value?
Yes.
Okay.
This critical value found from the standard normal distribution from this table. But then, because most normal distribution is not standard, not 0 and 1, right? It's like this. Then this is a uniform formula. Okay? For any normal distribution, we can convert this critical value to the critical value for this distribution. Anybody guess the results?
I got 306.75.
Very good. So optimal stock level, after we guess the critical value 0.675 with the optimal service level 75%, we guess mu is 300 plus 0.675 times 10. So you guess what?
306.75.
Very good. Liters. So that is your optimal stock level given the normal distribution. Clear? So you can see the hard part seems it's not rare that the reaction. I see this reaction every semester for student for this question. Okay, it's not that for inventory management, you guys is very clear. Okay, how do you calculate the optimal service now? CS divided by CS minus plus CE. The hard part finding students is that for figure out distribution. Even I guarantee all of you have learned uniform distribution or normal distribution before, but I know that's we forget some things, right? This is a good example to review that. Just remember that optimal service level is not enough, right? 75% is not enough. You can't tell your manager, okay, our optimal service level is 75%. You have to tell your manager the exact number corresponding to this optimal service level. This has to do with your demand distribution. Another thing I want to remind you guys is that this model, first we have talked about this model, right? For the shortage cost, it's too simple to estimate the shortage cost by unrealized profits. The first, keep that in mind. In reality, it's much, much higher than just unrealized profits. Another thing is that a lot of things here you have to estimate by yourself if you work for the company. For example, we have mentioned the salvage value. You have to estimate that. And especially demand. Well, this is a perfect demand. It's like your demand distribution is known in advance. But in many distribution, you don't know your demand. Is that uniform distribution or normal distribution or maybe some discrete distribution? You don't know. You have to figure out that. How to do that? Usually what we did is, again, historic data. We look at historic demand week by week. We collect like past 2 years weekly data. And then you can use Excel or any software. Try to fit these plots, like 100 weeks data, to see whether this is for normal distribution or uniform or some kind of distribution. And then you can use this fitting curve or distribution as estimation of your demand distribution. Okay, we can't teach in here. In the example, in your exam, everything is given. The demand distribution is given. But I can tell you in reality, this can be the hardest part for your job, to estimate your customer demand. Okay, it's not just forecast. I mean, forecast is like you forecast it, but you want to know the distribution. Like up, down, what is the distribution? Okay, it's uniform, it's normal, some other distribution. That's the key point. That's the end of today's class. I will see you guys on Friday. That's one team, you don't have your group pace